Hi, and welcome back to our Apes Flipped Classroom. So today we're talking about mining. So we're going to discuss different types of mining. We're going to consider what resources are being extracted from the ground, and we're going to discuss the environmental and economic impacts of mining. So our objectives for today are to be able to describe our different types of mining and to describe the ecological and economic impacts of mining. In order to do that, we're going to compare the different types of surface and the different types of subsurface mining, and we're going to discuss the economic value of the ores that are extracted, and we'll talk about why we mine. So before we get into the different types of mining, we really have to talk about some of the basics. So why do we mine? We mine to get to something valuable. We mine to get to ore. So the material that's mined is usually not the actual material that's desired, but something from which that material can be generated, and we call that ore. So we mine a particular area because it has a deposit of that ore or of that mineral. So here's your quick chemistry reminder. One of the main things that we mine are metals, and chemistry reminder, metals are elements that conduct electricity, heat, and they have important structural properties for building. So here's an example. So this rock actually is iron ore, and iron is one of our most important ores because iron is the primary material for steel, which is one of our primary building materials, as well as what we use to construct cars and motorcycles and everything we use for transportation. Okay, so next term is reserves. So when we talk about a reserve, we're talking about the known amount of a resource left that can be mined. And we usually measure this in how many years are left of extraction. And that's assuming that we continue to extract at the current rate. So if we look at this chart, we can see that globally, we have about 120 years of iron ore remaining. Now this table is from 2010, I believe. So probably only about 110 years left, but the US reserves are only 40 years. So that means if we continue extracting at the same rate that we're currently extracting, the US is going to run out of iron to extract in 40 years. So it's really important to know that for a lot of these metals, as well as a lot of the petroleum resources, that they're finite, they're going to run out. And especially with metals, this is why recycling is so critical. So this term overburden. So overburden is the soil and the vegetation and the rocks that are removed to get to an ore deposit that's near the surface. So they're just dug up and moved out of the way. So in this image, you're seeing these giant dump trucks, and these are giant. They would dwarf an ordinary truck. The ordinary truck is smaller than their wheels. And they just carry away the rocks and the vegetation and the soil, and they make piles of it nearby. And then our final term is tailings and slag. So tailings is the leftover waste that's been separated from the valuable metal. So it's those non-valuable rock components. But slag is a liquid mixture of waste products. So in this image, you see all these pools of brightly colored water. And slag is usually chemicals that are used to separate the valuable parts of the ore from the waste part of the rocks, and it's typically stored in pools on the mining site. And this is a really significant environmental risk because depending on the permeability of the soil, which relates right back to our soil texture that we just learned about, this may permeate into groundwater, taking all of those chemicals with it, or it may be carried away in runoff with overflow. So let's talk about our different types of surface mining. So first, just the reminder that when we do surface mining, we have to remove that overburden that covers up the ore deposit, and we store that in those big piles near the mining site. And then we see different types in this image. So we see open pit over here. We see the open pit mining. We also see strip mining here, where they dig one strip and then they continue making it deeper and deeper. You also have placer mining, which is a little bit unique. So placer mining is what you guys probably think of when you think of like the gold rush. So placer mining involves using a sieve or a screen to separate out sediment in a stream or river so that valuable materials like gold can be recovered. The final type of surface mining is mountaintop removal. And this is the most destructive type of surface mining. This typically uses dynamite or explosives to literally blow the top of a mountain off. So obviously that's going to be really damaging to the ecosystem. It's going to remove trees, it's going to remove vegetation, it's going to remove soil, it's going to lead to erosion because the root structures that held the soil in place are gone. Remember too that topsoil is a habitat for organisms. So we've removed both the soil habitat as well as the shrubs and trees as a habitat. We're going to increase stream turbidity because all those sediments that used to be held in place are going to be eroding down into the streams. And so finally, we're going to increase particulate matter in the air. There's a lot of dust in the air from mountaintop explosions. So from an environmental standpoint, this is the worst type of surface mining. All of these environmental consequences, topsoil erosion, habitat loss, increased stream turbidity, and increased particulate matter in the air, are present with all of our types of surface mining. They're just the most extreme with mountaintop explosion. So that's surface mining. But over here in the corner, you can see subsurface mining. So when do we do subsurface mining? As the ore near the surface gets more scarce because it's been mined, mining is going to move deeper underground to subsurface mining. And subsurface mining is more dangerous and expensive. Sometimes we do this because the close to the surface areas have been depleted. Sometimes it's just the type of mining. So coal usually is subsurface mining because the deposits are usually too deep to be accessed by surface mining. So when we have subsurface mining, so we're specifically going to talk about coal mining, but this is true of any type of subsurface mining. So subsurface mining is more expensive for the miner or for the mining company because of higher insurance and healthcare costs for workers. There's also a higher equipment cost. And there's a lot of, well, let's go back to the insurance costs. So there's a lot of reasons why the insurance is so much higher. There's a lot of accidents that occur. So there's a lot of insurance costs involved with that as well. So why is this so dangerous? So there's a lot of risks. Poor ventilation in the mines can lead to a buildup of toxic gases, most commonly methane, which can cause inhalation hazards or even death of miners. There can be a mine collapse. So if you have a shaft like this one, or like this one, if the shaft collapses, there's no way for the miners to escape. You might remember a few years ago, there was a story in the news about the collapse of a shaft in a coal mine in Brazil. In addition, there are chronic risks. So the inhalation of coal dust leads to a disease called black lung, which can cause cancer in miners. The inhalation of asbestos leads to mesothelioma, which can also lead to lung cancer for miners. And finally, there can be fires or explosions in the mine. Coal is flammable, and so if you have a fire in a coal mine, then it's very, very difficult to put out. So it's definitely not a safe work environment. So let's take a look at the anatomy of the mine. Usually you have a vertical shaft that's drilled down into the ground. Frequently there are two parallel vertical shafts. which does help a little bit with safety. Usually one of them is an elevator to carry miners down, and a second one that is used to transport the resource out. So they spread out horizontally along the seams. And so those seams they're just following the way that the coal is deposited in the rock. So they might curve upward, downward, left, or right, and it's just going to follow that coal. So whether it's for coal or another resource, subsurface mining becomes more and more common as the close to the surface deposits are depleted. Okay, so what are the impacts? So the first one is what we call acid mine drainage. So rainwater can seep into these abandoned mine tunnels, and it mixes with this substance called pyrite, which is a mineral that's exposed in the process of mining. And when pyrite mixes with water, it forms sulfuric acid. So chemistry note, that's battery acid. Okay, that's an extremely strong acid. So the problem here is that rainwater is going to wash that sulfuric acid out and into streams or even into the groundwater. And we just talked about watersheds. So you know that that water isn't going to stay where it's put, but it's going to flow down through that watershed and into all of those subsequent surface waters. So that can actually impact an entire watershed. And that acid is going to lower pH. Whoops. There we go. Of the water. And so that can take the pH of the water outside of the range of tolerance for aquatic organisms and kill them. It also makes toxic metals more soluble. So things like mercury, aluminum, and lead are more soluble in acidic water. And again, very, very small quantities of those will be outside of the range of tolerance of our aquatic organisms. Another issue is the release of methane. So coal deposits are usually associated with methane because they form from the same deposit of fossil material. And this has to be vented out of the mine to prevent suffocating the miners or any kind of explosion. And it's going to continue seeping out after the mine closes. And you might remember that methane is a much more potent greenhouse gas than carbon dioxide. And so this leads to climate change. And finally, we have lots of particulate matter that's released. So coal mining particularly releases a lot of soot and other particulate matter. And so it's particularly dangerous for the mine workers, but also for anyone who lives in the area or in an area where the prevailing winds bring this particulate matter into their area. So that's going to make them really prone to lung cancer or other respiratory issues like asthma and COPD. And then we already talked about these, but just a reminder, topsoil erosion occurs with mining. We're going to have habitat loss with surface mining, and we're going to have increased stream turbidity because all those sediments and soil particles are going to flow into the rivers and streams. So how do we address this? Well, one of the required pieces of legislation that you guys learned about this summer kind of gives us a hint. So SMCRA, or the Surface Mining Control and Reclamation Act, requires mine operators to reclaim the area. And reclamation is this process of restoring land to its original state after mining has finished. So you see this image of the mine during the mining process and then the mine after the restoration process. So step one is to fill in those empty mine shafts and holes. And so they're usually going to use that overburden and put that back in place. And then step two is to try and restore the original contours of the land. And you can see that they've at least attempted that in image B here. And step three is to return the topsoil, but in the process of returning it, make sure that the acids and metals and tailings have all been removed so that you're not putting back topsoil that could be toxic to any vegetation or animals that might live there. And finally, you want to replant with native plants. There are several reasons for this. Planting any kind of plant is going to help to decrease erosion and hold the topsoil in place, but planting native plants assures that the native organisms, native animals can move back in and find a safe habitat. Obviously, you're not going to have full-grown trees replanted in an area, so it takes time for this to recover. One of the requirements of SMCRA is that companies post a bond that is sufficient, so a large enough sum, to reclaim the land if they fail to do so, or if for some reason the company goes bankrupt during the mining period. And then depending on where the mine is, that bond is returned either 5 or 10 years after the mine is closed, if it has been properly reclaimed. So your practice FRQ for today, you're practicing proposing a solution. So in this problem, we have an abandoned coal mine site that's been found to have very high sulfur levels in the tailings and overburden left at the site. So you're to describe one environmental impact of this high sulfur content and propose a solution to remedy or reduce this impact. All right, I hope this has been helpful. I look forward to seeing you in class.